This is beta-lactam ring as penicillins. Now, in penicillins, it was 5-membered ring. And in penicillins, it was 5-membered ring. Now, here it is 6-membered ring. 6-membered ring. And so, which ring is more stable? 6-membered is more stable than 5-membered ring. And so, we can go one by one. You see, in next slide, I will show you what is difference between penicillins and cephalosporins. One by one. And so first, just introduction. Next slide, we can see. Uh, you see, it is antimicrobial agent, antibacterial agent, which inhibits cell wall synthesis. Like penicillins, they are also bacterial cell wall synthesis inhibitors. It was found in first from the fungal colony, in Sardinian sewer water, which is near Italy, between Europe and Africa. In that water, Sardinian Sea is there. From there they found this cephalosporin, first one. Okay. Now, the first identified penicillin is penicillin G. The same way, the first identified cephalosporin is cephalosporin CN. Cephalosporin C is the first identified cephalosporins. In 1961, it has been identified. Okay. Now, it is having thiazolidine ring, and beta-lactam ring, and which is thiazoline. This is wrong. And thiazolidine ring, thiazolidine ring, and beta-lactam ring, and the total this up to here, this ring is called as cephum. In penicillins, it was penum. Here it is called as cephum. What do you mean by cephum? How do you get this name cephum? You see, if you divide this name, so lactam, it was penum. So lactam in penicillins. Now lactam in cephalosporins. It was penum in penicillins. Penum, PN is for penicillins. Now here in cephalosporins, it is called as cephum. So it is lactam in cephalosporins. So this is the introduction. Now next, see. I told you. Oh. Here, this is penicillins, which is 6-APA, 6-amino penicillinic acid. Now, this is 7-amino cephalosporinic acid. 7-amino cephalosporinic acid is the which is present, basic nucleus present in the penicillins. Cephalosporins. Now, this is beta-lactam ring and thiazolidine ring. Now, here it is dihydrothiazine, and this is beta-lactam ring. The 6-membered ring is called as dihydrothiazine ring. See now, you see, in IU, I told you different types of naming, numbering. You see, in cephalosporin, in penicillins, what I told, numbering, we have started with nitrogen. 1, 2, 3, 4, 5, 6, 7. Here we have started with cephalosporins. We started with sulfur. This type of numbering is called as IUPAC numbering method. IUPAC numbering. In IUPAC numbering, when when heterocyclic compound is having multiple atoms, the order of preference will be oxygen first, then sulfur, then nitrogen, then phosphorus. These four are the heteroatoms which are present in heterocyclic compounds or drug compounds. And there is arsenic, that all is there, but that is not required for us. It is these four heteroatoms are mainly concerned with pharmaceutical preparations. And so this is the order OSNP. So there is no oxygen in this ring. So there is sulfur and nitrogen. So the preference should be given to the sulfur. Okay, 1, 2, 3, 4, 5. So there is one more method of numbering which is called as chemical abstracts, which is called as chemical abstract numbering. Chemical abstract numbering. So here the numbering starts from the atom which is fused atom. So this is the ring and this is bicyclic ring, no? So which is this is a fused ring. This is also fused ring. So fused atom. So the numbering in a chemical abstract, numbering starts from the fused atom. From the fused atom, the numbering starts on. Suppose in this, the fused atoms is carbon and nitrogen. The preference should be given to nitrogen than carbon because it's heteroatom. Carbon is not heteroatom. So even if you give numbering, say numbering if you start, still it becomes 7 and 1, 2, 3, 4, 5, 6, 7. So both way of numbering is correct. And if you give numbering with a heteroatom of fused one, then it is called as chemical abstract numbering. And chemical abstract numbering. Okay. What do you mean by fused atom? The atom which is common to two rings is called as fused atom. Or if you want to give by IUPAC numbering, go according to OSNP rule. OSNP rule. That means oxygen mode preference, next sulfur, next nitrogen, next phosphorus. So these are the two types of numbering. Both are correct. Okay, any doubt here, please? No doubt?
No.
No doubt.
Okay. Thank you. Now, both the namings are correct. And anytime, sometimes textbooks give this type of numbering, sometimes they give this type of numbering. Both are correct. Now, you see the side chain at the amine group is 7-amino adipic acid, which is present in cephalosporin, whereas here it is acyl side chain. Acyl side chain. Now here it is 5-membered ring, where in penicillins it is 5-membered heterocyclic ring, whereas here it is 6-membered heterocyclic ring. So 6-membered ring in cephalosporins is bigger ring and less strained and less reactive. So they are more stable drugs. Cephalosporins. And penicillins, it was discovered in 1940 or 1920 something. Cephalosporins 1960s it was discovered. So these are what is that? Smaller brother to penicillin, smaller brother to the penicillin. Advantages with these drugs, see, we can learn next slide. Here, advantages: non-toxic drugs, less allergic reactions compared to penicillin. One advantage is that less allergic. So for some patients, So penicillins may not be suitable. So they cause what is that anaphylactic shock, even death we may get it, and even there may be fatal to the patients. And in that conditions, patients who are who are susceptible to penicillins, hmm, or who are allergic to penicillin, the next preference of drugs is cephalosporins. And cephalosporins are more superior drugs. Again, I'm telling, cephalosporins are more superior drugs. And then more acid stable in acidic condition. Why? Because of six-membered ring, more stability. So there is no pressure on this beta lactam ligand. Not more, the pressure exerted by beta, what is that? Penicillins is more than cephalosporins. Next, more stable to beta lactamase enzyme. Next, good activity against gram-negative bacteria and as well as gram-positive bacteria. Now, disadvantages you see, this is disadvantage of cephalosporin CN. What we are discussing is cephalosporin C. Here, poor polar due to side chain. This is adipic acid, is a carboxylic group, amine. It's nothing but amino acid. Amino acid. So more polar. So it was very difficult to isolate and purify the compound. Low potency. What is the disadvantage with cephalosporin CC? Overall drugs, cephalosporins are superior drugs. Again, I am telling, cephalosporins are superior drugs. Now, low regarding this cephalosporin CC, low potency, limited treatment to UTI infections, and like quinolones, these are also, they were showing more drugs to the urinary tract infection because they are concentrated in the urine. And water soluble, and urine composition is 90% water. So what was the problem? Not observed orally. Not observed orally. So they done. So what was the advantage with this? Is that it can act as a lead compound, and it can act as a lead compound. Lead compound is one raw material type, and we can modify it and convert into different drugs. And so actual definition means lead compound is one which has pharmacological activities that can be high or low, and we need to trim them, change some functional groups and make it into less toxic and more effective drug. So this is an now see SAR of penicillin. So this is the basic nucleus. 7 APA, 7 amino cephalosporinic acid. 7 amino cephalosporinic acid. Now, similar to penicillins, SAR similar to penicillins. Beta lactam ring is crucial to the mechanism of action. Now, carboxylic group at 4th position is important for binding, that is peptidoglycan layer, PB, peptidoglycan protein, very important carboxylic group. Then bicyclic system, this is important, and more important thing is that it is less strained molecule than penicillin. Stereochemistry is very important. In penicillins we were having 3 chiral centers, and now it is only 2, that is 6 and 7. Both are in alpha configuration and cis isomerism. Because both are in one plane and configuration. Then now you see acetoxy group. This is acetoxy group present. Acetoxy group. Acetoxy group means CH3 C double bond O is called as acetoxy group. C double O minus is known as acetoxy group. CH3 C double bond O minus is acetoxy group. Is important for mechanism of action. Then, so what are the possible modifications we can do it here? That is 7 acyl amino side chain. This side chain we can change modifications. Then we can have some modification on a third functional group, that is acetoxy group. Then there are some drugs which has extra functional group at C7, extra functional group at C7, and there are some drugs which have with carboxylic group modifications on with the carboxylic group modifications on. So these are this is SAR in one slide. So please try to concentrate. It will be lengthy. Don't leave anyone. Please write your for attendance. Write your comments and so now. Okay. Now you see. Now what they done? Adipic acid. What is it? Cephalosporin C. There was problem because of isolation. There was problem with isolation. To avoid that, what they done is that they replaced that adipic acid portion. Adipic acid is this one. This is the adipic acid. This is adipic acid portion. That they replaced with uh, clear. Let me clear. With acetothiazone. Acetothiazone. Thiophene ring. Sorry. Acetothiophenone ring. Which we got cephalothin. What's a drug which we got after cephalosporin? It is cephalothin. Cephalothin is a drug which we got where adipic acid has been replaced with a thiophene, acetothiophene group. See, this drug, cephalothin, it's a first generation drugs and it's a first generation drugs. Like penicillins, this drug is also more active towards gram-positive bacteria. More active towards gram-positive bacteria. But very some gram-negative bacteria. Some gram-negative bacteria. So all cephalosporins will be having more activity towards gram-positive bacteria than gram-negative bacteria. It's a general statement. First generation drugs will be having more positive towards gram-positive bacteria than gram-negative bacteria. Then, less likely to cause allergic reactions. Useful versus penicillinase producing strains. Penicillinase is beta-lactamase enzyme now. Against that, this drug can act. First they found this penicillinase enzyme in Staphylococcus aureus, and so it is also active against that. But this Pseudomonas aeruginosa, this also produce penicillinase. This microorganism is a gram-negative bacteria. This also produce penicillinase, but it is not able to act against that. One more thing is that this drug should be given only by administration, by injection. It can be administered by injection. It is not able to given by oral route of administration. Oral route of administration. Now, see, what is the reason they started finding it out? So, what was the reason is that hmm, cephalothin uh, on metabolism, this is an ester group, no? Acetyl group is an ester group. By esterase, it gets metabolized to give methoxy group. Methoxy group. So the formed hydroxyl group, there is formation of hydroxyl group on actually it will be like this one. O C double bond O CH3. Now what happened by hydrolysis process or esterase enzyme, it breaks this and you get this compound plus acetic acid plus acetic acid you get it. So now this molecule, this metabolite is less active. That's why cephalothin, if you want to use cephalothin, it is only by route of injection you have to give it in, by IM or IV. Excuse me. You can't give by oral route because the drug is getting metabolized. And this the produced hydroxyl group causes some effects. Let us go into next slide and see that. Next, let us go to next slide and see what was the reason. See, hmm? the produced here. This is the what is the cephalothin or derivative. Now this when by esterase enzyme it is getting hydroxyl group. This hydroxyl group, what it does now, it undergoes internal reaction to form a lactone ring. See, this is a lactone ring is formed here. Lactone ring is formed. So this lactone ring, so when this is there, no, when there is a lactone ring formation, still there will be beta lactam ring, but it is not able to show any actions. It doesn't show any biological activity. Here, those cephalosporins that have astaxy group in side chain are subject to hydrolysis in the body. Hydrolysis in the body. The resultant hydroxy methyl group. This is hydroxy and this is methyl group. At C3 is poor leaving group. So now you see hydroxy methyl moiety reacts with carboxyl group, carbonyl group of carboxylic group to form a lactone ring. This results in activation of drug, though it retains beta lactam ring. What is the important thing? In first we learned, no, this carboxylic group is very important in peptidoglycan layer synthesis blocking, and this will bind to that beta lactamase enzyme. Now what happens if there is lactone formation, there is no carboxylic group. So this carboxylic group, which is very essential for peptidoglycan layer synthesis blocking action, is stopped. So how did they encounter this? How did they encounter this problem? You see, by making this was what happened. Hydroxyl group is a poor leaving group and it cannot go out from the reaction. It is staying for longer time and reacting with this carboxylic group and forming a lactone ring. So we need to have a good leaving group. And so even if it forms, it should go out. And so that was the strategy. Let us see what they done. So instead of, say this is the same thiazole ring, everything is same. Instead of acetoxy group, they place pyridine molecule here, pyridine molecule. Now this molecule is stable, it's good living group, and this carboxylate group, whatever is there, can react with beta lactamase enzyme. Beta lactamase enzyme. So what is the drug name here? Cephalosporin. See, all the names look similar. They, all these drugs are like twins, and so you can't identify the twins, no, same way here. So the names are very tricky. Hmm? So this is the reason why this they have introduced pyridine molecule. What is the ring of? What is the name of this ring? Pyridine molecule or pyridinium. Plus is there, no, pyridinium ion. So in examination, I may give this drug structure and asking you to write what is the name of this ring, what is its importance. Now you need to explain that, telling that this is pyridine, good living group, it is metabolically stable, like that. But what's the disadvantage, you see? Hmm? Still, this should be given by injection, though it is mm, metabolism is improved, but should it still it should be given by injection and poorly absorbed from the gut. So let us go for next slide. Now, cephalexin. See here, if you remember this structure, this is like ampicillin. Everything is similar to ampicillin, except here it is 6-membered ring. In ampicillin, it will be 5-membered ring. 5-membered ring. So this you see, they brought the concept what they found ampicillin. They found they thought that this ampicillin principle, if you include here, it could result good drug like that. Now see what are the changes they done. Hmm? They removed that pyridine molecule and placed only methyl group here, and they brought amine group. They removed even heterocyclic ring and brought a benzene ring here. Benzene ring. So it has so cephalexin, very good drug. And one more thing, cephalexin is not a broad spectrum drug. Generally, we confuse that cephalexin is a broad spectrum one. No, why I brought no, ampicillin was broad spectrum. Ampicillin is a broad spectrum. Do not think that in the same way cephalexin is also broad spectrum one. Cephalexin is not a broad spectrum drug. It is only acting on gram-positive bacteria. So now you see the methyl group at position 3 and the phenyl group at R of cephalosporin C forms cephalexin. Now the methyl group present in this group A ring, A ring prevents metabolism, thus maintain potency. Now this amine group on the side chain prevents neighboring group participation and thus making it into orally administered drug. Cephalexin we can take by oral route of administration. Oral route of administration. So this drug, see till now cephalosporin, it also should be given injection. Then cefazolin should also be given by oral route of administration. Penicillin C, first drug, difficult to isolate. This was the problem with this drug. Then Cefazolin was very good, but injection we have to give. What is the reason? It's metabolism. Then what happens is that there is formation of lactone ring. Again, I'm telling. Hmm? Then you see next drug is that they placed pyridinium ion, that also resulted in wrong. Next is that ceflixin. They got good drug which is orally effective one. Why? Because of this methyl group and this amine group one. This prevent neighboring group participation. There is no chance of metabolism here. So this drug can be given by oral route of administration. So do not confuse that. This is like penicillin, no? Do not think that this drug ceflixin is also broad spectrum one. Broad spectrum. It is not a broad spectrum. Not a broad spectrum. Again, I am telling it's not a broad spectrum one. Now, it is used active against gram positive bacteria, but limited activity against gram negative bacteria. Limited action towards gram negative bacteria causing UTI infections. Now, one more drug. See, it looks like amoxicillin. Previous drug, cephalexin, it look like ampicillin. Now, cephadroxil looks like amoxicillin. See, because of presence of hydroxyl group, amoxicillin. Orally active because of this methyl group and this nation. See, because T off of this drug is very high and once a dose, one dose is enough for day. Prolonged duration of action, especially this cephadroxil is used to treat urinary tract infections. Urinary tract infection. Why? Because uh, is related to slow urinary excretion. The drug is slowly excreted by urine, so it is concentrating in the urine. This is the about cephadroxil. Now, so till now, what we studied about first generation drugs. You see, we are reading first time, no? So I brought everything in one slide. Now I don't put second and third everything like this. So what is that? Generally low activity than penicillins, better range of activity uh, comparable to penicillins. That means more microorganisms, ranged, best active against gram positive cocaine, useful against gram negative. Useful against gram negative. See, useful against Staphylococcus aureus. Methicillin resistant Staphylococcus aureus is there? No. Uh, Methicillin resistant MRSA. Against that, these drugs can act at. And streptococcal infections, when penicillin has to be avoided, especially in allergic reactions and anaphylactic conditions. Why? These are poorly observed because of 3-methyl, except 3-methyl groups. Then resistance nowadays, no, these are very good drugs for gram positive.